Dag. Lots of stuff going on. So let's do it. And when I say it, I mean the daily space weather. And welcome to the Smash News Network. Least busted name in news. Welcome to space. As we bring you the most detailed imagery of the sun and comprehensive space weather you'll find in the known universe. We've got new sunspots. We've got lots of flaring, a major uptick in solar activity in general. Huge filaments also, including at least one which has a name. Crown prominence up there in the northern polar region. It's pretty minor, but just south of it, down here, we've got a major sunspot, which is producing some major flares of the M-class variety. And don't be surprised to see an X-class variety flare in the coming days, as there's, again, lots of stuff to cover when it comes to space weather. Also some active setting regions down there, some coronal mass ejections to cover. Nature, it doesn't take a break, and typically we don't do so either. As we're pushing 6 years of daily space weather videos, having only taken about a week off total time over that entire period. Here's a close-up of this quite active sunspot. And to its north, we've got another large sunspot group having just risen. Let's take a step back here and look at our SDO intensitygram. And major sunspot groups there in the northern hemisphere, one rotating in the southern hemisphere, and another group here. We'll have like 3 more named sunspot groups today as a result of these areas forming and rising in the northeast. Here's your SDO magnetogram, colorized variety. That is yesterday plus today. And let's see what's going on Crescent Earth for a brief moment here in terms of what volcanoes are erupting. Shivaluch is producing a 22,000-foot plume of volcanic ash. It's a flight level 220, flight level 070 over Sakurajima. Suwanosejima, flight level 040. And Karengatang, now back on the list. A possible, the definite eruptions occurring at Karengatang. And in fact, right here is an image of it. If you want to go check that out, you can find it on the volcanodiscovery.com page. So that's located in Indonesia, as that eruption is intensifying. Popocatépetl exploding in central Mexico, flight level 220. It's a 22,000-foot ash plume. Headed down to Guatemala, 15,000-foot ash plume over Fuego as Fuego explodes. Nevado de Ruiz exploding, flight level 200. Sangay exploding, flight level 200. 22,000-foot ash plumes from both of those volcanoes in South America. Headed down to Peru, Sabancaya exploding, flight level 210. It's a 21,000-foot volcanic ash plume. And Lascar, now possible eruption imminent there at Lascar, as there is a lava dome that could collapse or explode, creating pyroclastic flows, ballistics, or ashfall. Let's move to seismicity for a brief moment here. There's the past 90 days from volcanodiscovery.com's convenient bar graph. And let's see what's been happening as far as seismicity. Of course, lots of aftershocks continuing there in Turkey, like this 5.1 that came through at 14:20 yesterday afternoon, Universal Time. One of the largest quakes of the past 24 was at Honduras. It was a 5.5. That was at 15:16 Universal Time. Also, Papua New Guinea had a 5.0. Indonesia had a 5.1. And South Sandwich Islands region there, moving back into the seismically active portion of the coverage. South Sandwich Islands saw a 5.4. A pretty unpopulated portion of the planet indeed, and the largest quake of the past 24 just came in at of 5.6 magnitude, 10:53 Universal Time. For that one at the Solomon Islands. So getting back to space here, and there is some spectacular imagery of the past 24 hours from SDO 171 angstroms. And before we blast through all of our relevant space weather data, we would remind our viewers to please support the channel if you enjoy the content and prefer to see it continue to exist and remain publicly visible for all to see. Please support the channel via the links in the description. You can find the Patreon link down there. Today's featured product is, which you can find via our Redbubble link. It's because reasons. Why is there zero accountability? Why does censorship continue on big tech sites despite it being exposed by Elon? Why does it still exist? Why hasn't it been abolished entirely? Why have the business models of these corporations been self-destructing? Well, because reasons. Why is there zero accountability for all of the fraud, propaganda, and disinformation that's been shoveled onto your screen in the past 3 years? Because reasons. So that's part of the reason why we put out this latest design. This is our latest design here, depicting certain commonly known objects like intercontinental ballistic nuclear missiles and flaming Earth, and a syringe, and even the CDC logo makes an appearance on the design. Also, the ever-popular mask. If you click the Redbubble link below the video, you'll find our products in order of best selling. They may or may not reflect the views of Smash News Network, least busted name in news. Some of them may or may not reflect the views of our viewers, and some of them may be just for fun. In any case, congratulations on surviving a global scamdemic so far. You're doing a fine job. The best way to support the channel is perhaps via the Smash Team membership. It's kind of like Patreon, but we replace Patreon with our own superior site. So we also send out email alerts because we don't trust certain organizations to let our viewers know when we put out a video. And good morning to you as well, TinMan1057. SmashOnMash.com/Smash Team is our own subscription services site, launched back in October of 2021. There's a gold level, there's a silver level, there's a bronze level. There's even a gold annual paid-up subscription, which is the best value as it includes complimentary merch. And let's move on to some more space weather. 10.7 centimeter radio flux now pushing 200 solar flux units. And for you new viewers, a 10.7 centimeter radio flux emanates from the upper chromosphere and lower corona, about where my pointer is. And it is the most proportional proxy we have to sunspot number. There you can see those proportional little spikes here, how proportional the black line is to the red line. And we can expect this to increase once again today. So expect the radio flux to exceed 200 solar flux units today, and expect the sunspot number to push up toward 170, as we'll have a number of new named groups here that are not yet counted, as Solar Cycle 25 continues to ramp up, not down. Next, our space weather enthusiast dashboard here, not forecasting any geomagnetic unrest or geomagnetic storms. No arguments there from me. Let's continue on to look at global geomagnetism. There's the KP index. It is currently at 3.33. Geomagnetically calm condition there. And here are the last 4 hours of Earth's magnetic moment from space. If you want to know how this model is derived, head to the Geospace Magnetosphere Movies page and click on Details. That'll link you to the Space Weather Modeling Framework, and you can download all the software and analyze the data yourself. It's derived from all sorts of things, from magnetometers to electron flux to the solar wind measured at Lagrangian point 1. Again, that's the last 4 hours, Earth's magnetic moment from space. Here's the last 4 hours, Earth's magnetic moment from the ground. Our ground magnetic perturbations map, Geospace Delta B, refers to changes to Earth's B field. The units depicted here are nanotesla magnetic flux density. We are seeing some equatorial variations there in Earth's B field likely. And let's continue on to the real-time solar wind. So it looks like we did indeed see some minor CME impacts, very minor, and we kind of did forecast them to show up mid to late day yesterday. So there's one minor impact, it looks like, as we see this dip in the plasma temperature, a minor uptick in the speed, and a minor downtick in the density. So that's also the phi angle shifted here briefly. And then, of course, the magnetic field shifted when that subsided. Also a second impact here, likely. Two little tiny diffuse impacts there, barely detectable. And no big deal there. Wouldn't have caused much of anything to happen at Earth. Keep in mind, these measurements are made at Lagrangian point 1. And those spacecraft at Lagrange 1 don't have a magnetosphere like Earth does. Anyway, current conditions are just over 500 kilometers per second for the solar wind speed. Solar wind density here, only about 3.5 protons per cubic centimeter. This solar wind coronal hole high-speed stream is subsiding at the moment, and we're having a huge increase in the electron flux. We'll get to it later in the video. Goes magnetometers there. We should see these smooth out in the next day or so, as it'll be a while before we see any coronal hole high-speed streams. There's the current situation. And as far as the current sheet, the Earth is now in a North Pole-oriented current sheet. So welcome to the North Pole, the North heliographic pole, the North magnetic pole of the heliosphere. So that's our top view ecliptic plane field plot. We've also got some corrections to make about stereo A. We'll get to it in our bonus features segment when we talk about coronal mass ejections. Next, our line of sight field plot. Here the sun's B field is depicted in blue, north solar polar field in green, south solar polar field in red. And let's move to coronal holes, as we do have some North Pole-oriented coronal holes rotating in here. They are right around the equator, although they are not very well defined. Keep in mind that data is nearly an hour and a half old from the time we streamed. So let's take a look at SDO 211 angstroms. Probably the best wavelength to view coronal holes. And again, these areas over here, these are North Pole-oriented coronal holes here. They should be a little more well-defined in the coming days. The bumpy corona has a tendency to obscure those coronal holes. As that rotates toward the Earth, it'll be a little bit more obvious. Next, we'll look at sunspots briefly. And we've got a lot of groups. So we can expect to see at least one more named sunspot group, this really large group here behind 3218. That'll be 3219. There may be another one or two around this area in the northeast as well. So again, expect an uptick in the sunspot number because this group here, this large group that's just risen, is quite large and contains many, many umbrae. So sunspot number and radio flux are likely to increase substantially once again today. Here's a close-up of the SDO continuum wavelengths, I should say. So yeah, this group here will get a name, and also this group that just wrote. There are at least two sunspot groups there. So you may see a sunspot number increase of maybe 60 or 80 sunspots there added to the sunspot number today, despite these setting groups down here. And let's take a look at flares and energetic particles. No spikes in the proton flux. No relativistic particles showing up anytime recently. We brought up the 1 week chart here of the X-ray flux to show you this recent huge uptick in solar activity. There may be many YouTube channels that talk nonsense about space weather that will be telling you that they were right the whole time and they called it and so on, even though they couldn't forecast their way out of a wet tissue paper greenhouse. There's the 3-day chart to show you a little more detail. Several M-class flares, no less than 6 M-class events since yesterday's daily space weather video. And let's take a look at some of the best wavelengths through which to view solar flares: 94 angstroms and 193 angstroms. That's the past 24 hours. Here's 131. And this area over here remains quite interesting as there is quite a lot of plasma hanging out. Quite close to the equator there. So we've got sunspots at drastically different latitudes, which has been a feature of Solar Cycle 25 that's been enduring. We keep seeing sunspots at high latitudes, an indication that there's a long way to go to reach solar maximum. Next, we've added 171 angstroms for the visual aesthetics. That's 131 plus 171. Let's take a closer look at this sunspot in the northwest. Great imagery there from SDO. And let's take a close-up look at this very active, rowdy region down here. Many CMEs coming from that area already, as well as quite a few flares. Let's take a brief look at what's going on overhead. This is the sky over Lehigh Valley at the moment. And we've got the moon there in the constellation Virgo. Low in the sky, we've got Mercury, which you may be able to see if you've got a clear sky and a low horizon and low light pollution before dawn. Next, we'll do a solar system forecast. Heavenly bodies are located about there at the moment, and we'll advance this 1 week. Here's where things will be on the 16th. We will have a crescent waning moon as we push toward the February new moon. Continuing on to look at some coronagraphs. We've got limited data, and before we talk about stereo A, let's talk about its location. It's not located at Lagrange 5. It's actually like way over here. It's somewhere around there. It's much closer to Earth than at Lagrange 5. And shout out to Dr. Keith Strong for correcting me on that. If you want to see stereo A's location, just look at the stereo website. It'll show you the actual spot. There's also a tool to calculate its location on a given date. That thing was launched all the way back in 2006, and it's gone all the way around the sun, and now it's about to pass Earth once again. So just so you're aware of that, it is behind Earth orbitally speaking. It does see space weather ahead of Earth. However, it's not actually at Lagrangian 0.5. It's about 1/3 of the distance to Earth. It's like way up here where my pointer is, as opposed to way out there at Lagrange 5. So just a little correction there on stereo A's location. It will soon overtake Earth and then be like stereo B, because it'll be seeing space weather that's behind. Anyway, here are the coronagraphs, and we do see some coronal mass ejections. They are not earthly directed. If you're a new viewer, you may not be aware that from stereo A's perspective, Earth would be off on a line like this. And of course, we don't see any ejecta headed down that line. So it's pretty easy to conclude that there are no additional Earth-directed coronal mass ejections. It's pretty clear in between the Earth and the Sun right now. Not a lot of plasma out there. Here's the last 24 hours in composite. And thanks for leaving a comment, Jackie, too. Here's a little closer up view. So quite a few CMEs there. None of them are anywhere near the Earth. Here's an even closer view. And that, my friends, is a good time. Next, let's look at filaments, because we've got a massive number of filaments and a massive number of sunspots and a really high likelihood of Earth-directed coronal mass ejections. So let's take a look at that. That is the National Sunspot Observatory Helium Alpha Telescope located at Cerro Tololo, Chile. You can See all those dark absorption features there? Those are all filaments. Over here, these are also filaments. When they hang off the edge of the solar disk, we call them prominences. It's just a specific type of filaments. And of course, this is the Hulk Hogan down here, and this is the Tom Holland up here. And perhaps some of these other filaments need names? I don't know. You be the judge. Let's bring up the latest image. We see a filament forming right there, spontaneously, just popping out of that active region. And if you'd like to name filaments, do it on our Twitter feed. So you're invited to name that filament. Filaments are super relevant to space weather because if they eject and then they strike the Earth, they could cause geomagnetic storms. They could even cause power grid failures. They might cause a local transformer to explode. So we cover them. And that's one of the many reasons why you ought to join us on Twitter. If you don't have an account on Twitter, make one. I know the censorship is truly pathetic, just like on Meta and on YouTube and on Apple iTunes. It's a concerted effort to censor people. So you're needed over there. By the way, if you want some free mushroom gummy samples, you can find the link on the Twitter page at Smash-O-Mash, all over the internet at Smash-O-Mash. No, we don't expect you to see it. We don't expect anybody to see anything. We expect to remain utterly, utterly shadow banned in all of our endeavors. There may be a lawsuit coming to a criminal organization near you. Anyway, this is the last 24 hours in SDO 304 angstroms, a great wavelength ionized helium to show filaments. And since we've shown you the last 24 hours, let's show you the last 2.5 hours from the GOES 16 SUVI, since there is an additional coronal mass ejection happening as we speak. So plenty of activity to cover here. This crown prominence, also something interesting to look at with this wide field of view from GOES 16 SUVI. Another CME propagating around the eastern equatorial region. That's what's going on. And let's move to our bonus features segment. So we do have some charging hazards here. We've had a major increase in the electron flux, which we'll get to here in a moment. Currently, we've got surface charging hazards over the eastern Pacific, moving into the central Pacific. Low energy electrons there building up on the outsides of satellites. A precipitous increase in the electron flux here. And actually, NOAA forecasted it. It's something we typically do see at the end of coronal hole high-speed streams. So there is the electron flux for the past 3 days as measured by GOES 16 and GOES 18. There is the forecast expecting a further increase. I would tend to agree with that, as it has been a fairly high-speed coronal hole wind stream, just not very high density. And there's the one-year graph to put it in context. Keep in mind that electron flux is measured at the F layer of the ionosphere by those satellites, so let's take a look at the vibrational frequency of that portion of the atmosphere. Feel free to pause the video on this frame if it helps you. So here's the vibrational frequency of the F layer. Anyway, that's what's shaken. Let's bring up the latest image here and show the anomalygram. There's the anomalygram. Huge anomalies here, especially south of the equator. Southern Hemisphere summertime featuring tons of high and low frequency anomalies. And as you may expect, the most anomalies are occurring around the South Atlantic anomaly, which is now back over the South American continent somehow. Let us know in the comments if we were the only channel that noticed the migration of the South Atlantic anomaly. I didn't hear anybody else say a single word about it, and certainly didn't credit us with noticing. Anyway, there's the latest image, 12:45 Universal Time ionogram. Oops, 12 o'clock Universal Time ionogram. And 12 o'clock Universal Time anomalygram. That's anomaly in megahertz from a 30-day median. We'll also show the total electron content. It would be the free electrons from the inner portion of the outer Van Allen belt, which is at about 12,500 miles of altitude, all the way down to your handset. That is a long run, and those free electrons can cause massive signal diffraction. Refraction. So these are the most likely places to see GPS errors, folks. And you can expect to see this become a little bit more organized with these higher levels of electron flux. In other words, GPS errors should be a little bit lower. In North America here, you can expect to see these electrons a little bit more concentrated around the equator at noontime, which is the place most GPS errors occur. Last but not least, for our space weather portion, let's take a look at the latest intensitygram and latest magnetogram. So that is quite a lot of activity indeed. A ton of huge sunspots here, including two massive ones here just rising in the east. That new one there, oh, it's pretty big. It's got another group leading it, so at least two new named sunspot groups there. Let's take a look at the fields. And at the moment, I'm going to say that's an alpha class sunspot, since I only see one magnetic field polarity there. There's the full rock back. Many of these groups are beta gamma class and beta gamma delta class. Likelihood of major solar flares, including X class flares, greater than 50%. More likely than not to see large solar flares. So we'll get to meteorology here in just a moment. First, if you haven't checked out the links below the video, you can find links to the Hemp Lucid shop. Thanks to everybody who's picked up product from the Hemp Lucid shop. Bundle and save. Save on shipping. Perhaps pick up some Valentine's Day gifts from Hemp Lucid. Shop by solution like stress, immune response, sleep, focus, etc. All kinds of different products there, including CBD body balm, lip balm, etc. Lots of ways to save. Thanks again, everybody who's helped out the channel and helped out your own health by picking up some products from Hemp Lucid, our latest and perhaps greatest affiliate. Also, help us out with clicks by visiting our own website, smashomash.com, and welcome to the Neo Renaissance. Again, congratulations on realizing the channel exists. You can find all kinds of links to our social media and so on over there. Links to the Redbubble shop, the YouTube channel, Patreon, a permanent invite link to the Discord chat, Hemp Lucid, and lots more on the homepage, so visit us on the interwebs at smashomash.com. Press like excuse me, press like and subscribe if you enjoy the content. Tell your friends and foes about us. Once again, if we reach 50 likes, that's all folks, 50 likes for us to do a live stream. Yesterday we had 150 views on our daily space weather video, but we did not even reach 50 likes. So if you're viewing the video, maybe press the like button. Just saying. If you'd like us to stream live, if you've got a question, if you'd like to appear on the video, we would consider doing a Discord chat, giving you a call, etc. So press like. Press like and let us know in the comments that you were able to actually see the video. Next, looking for low pressure. We've got some pretty low pressure here in the Arctic Ocean, all the way down to 952 hectopascals. Is that the lowest pressure in the world? Well, certainly not. We've got a significantly lower pressure here in the Southern Ocean, near the Drake Passage there. So very low pressure there around the border between the Pacific and Southern Oceans. Just west of the Drake Passage, that is the planet's lowest mean sea level temperature. Not temperature, pressure. The lowest mean sea level pressure. So Southern Ocean there featuring some quite low barometric pressure indeed. Next, we'll show you global wind currents. There they are on the surface of the east. There are the jet streams. Jet stream divergence happening there in the Central Pacific. Jet streams of the Western world depicted here. Surface winds depicted here. Surface winds of the central world here, and these are the jet streams. And let's blast through the rest of our meteorology segment, as we don't want the video to be too lengthy. And thanks for leaving a comment, One Audio. So these are the clouds and fog over the Americas. We use the 3.9 nanometer radiation infrared satellite when it is too dark to use the visible. We've got a strong low here moving across the U.S. We'll get to it momentarily. First, our weather.gov map. So if your location's lit, click your location. It looks like some good surf around Hawaii. Once again, we'll scroll down to show you the key. Weather.gov is where you can find that map. And let's look at some forecasts. So here you've got this low. It's moving into Illinois right now, moving toward Lake Michigan. A second low will form in about 2 days in southern Georgia. So also that current low is bringing some quite heavy snow on the northwestern edge of it. Some quite heavy and wet snow. It'll be bringing some significant icing to New England. That's your 72-hour GFS pressure and precipitation forecast. Since a lot of that precipitation will fall in the form of rain, here is your total accumulated precipitation forecast. Some heavy rains there coming to the Florida Panhandle, Georgia, South Carolina, and Alabama. And since some of it will fall as snow, here is your total accumulated snow depth change in inches. It's the same model, the GFS 72-hour. Some heavy snows coming to portions of California once again. Another foot expected in some of those areas. Crazy amount of snow around the California-Nevada border. And I mean for the whole season, not just during this 72-hour run. Next, let's look at precipitation type. A great tool from windy.com. Precipitation type, I like it. It tells you where the rain and where the snow's fallen. It also shows you wintry mix and wet snow and so forth. Windy.com, they got a great mobile app. Check it out, perhaps. And we've had some heavy lightning here, stretching from the central Gulf all the way up into the Gulf states. And let's see if we have any terrestrial strikes by looking at lightningmaps.org. Our real-time lightning map. And at the moment, we've got some active cells in the Gulf. There is the thunderclap propagating. Pretty calm here as far as lightning goes. Not a lot of lightning on planet Earth at the moment. Next, we're going to close this mother out by showing the U.S. Doppler radar. Massive amount of moisture there. St. Louis, things have just cleared up for you there, but the low is practically right overhead. So you could see some additional snow showers here coming in throughout the day today. The likelihood of that will drop as the sun rises. Because remember, folks, it's more likely to precipitate if the temperature drops than if the temperature rises. So you're more likely to reach a dew point at a given temperature. You're more likely to reach a dew point at a given pressure and humidity if the temperature drops. That's just how precipitation works. Water will then condense and become droplets. Anyway, there's your water vapor map. You can see this huge pressure gradient being created here on the northwestern side of that, as there's a huge mixture of cold and warm moist air there happening. Here's your recap. U.S. Doppler radar map, ground-based system showing vertical motion of water droplets and ice crystals. Shortwave radiation, which is the 3.9 nanometer infrared band. Great at showing clouds and fog when it's too dark to use a visible satellite. And there's the water vapor map. It shows all the water vapor. Likely clear skies over central Florida here, as there's dry, massive air overhead. In fact, there's even a high pressure zone here, somewhere around the Caribbean. So we can see clearly this clockwise rotation there, an indication of a high pressure zone, an anticyclone, if you will. Anyway, thanks for tuning into the Daily Space Weather. We hope it was enjoyable for you, and we'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-a-Mash, signing off. And may that solar wind be at your back.